This would be a very interactive thing. If you have questions, we're going to go through some design and architecture decisions we made about designing a relational database optimized to run in the cloud. Okay, so I want to first tell you a little bit about who we are. When I say we, the company I represent, which is Enterprise DB, who happens to be a sponsor for the third year in a row, a founder of this event, and very active in the Postgres community. I'll talk about that in a moment. I want to tell you what is Postgres Plus Cloud Database. That conjures up a lot of images, and people think of cloud and database, and so I'll talk to you a little bit about what it is and what it's not. What we were hoping to accomplish in designing, developing, and delivering Postgres Plus Cloud Database. But I think we'll kind of, for the technical folks, we'll get into a little bit of the architecture, and this is why Dave Page is here, and he has our actual architect, who was originally scheduled to give this presentation on Skype. So if you guys manage to stump me, go gentle with me. I am a manager. I'm a vice president, so I only know a little bit of, only a little certain level of depth on the architecture. Then I'll talk about scenarios we support in the cloud, and they're things that we can do in the cloud when deploying Postgres or in the Postgres Plus Cloud Database that we typically can't do in a traditional data center or bare metal implementation. I'll tell you about why that is. And when I say the cloud, I just don't mean Amazon. I mean a variety of different cloud deployment platforms. Okay, so a bit about who we are. So Enterprise DB, we've been around for about 8 years. We're a Postgres products company. There are a lot of services companies out there. We do professional services around Postgres. But our primary business is around products. We make a version of Postgres called Postgres Plus Advanced Server. For every release of Postgres, there's a release of Advanced Server. When Postgres 9.3 comes out, a month or two later, out comes Postgres Plus Advanced Server. What's the difference? One of the primary differences is we add Oracle compatibility and a number of tools for migrating from Oracle to Postgres. That's our primary business, is migrating people off Oracle to Postgres. And it's been everything. Again, we've been around for a while, and we have strong investor backing. But I would, in short, I would describe us as a Postgres products company. We employ many members of the Postgres community. Bruce Momjian works for us, as does Dave Page, Robert Haas, who are all here and presenting. And we do a lot. We contribute a lot of features to Postgres. So the materialized view feature that's in Postgres 9.3 was our work. And we're working on the beginnings of parallel query for 9.4. And we do a lot of things. We do build. So we try to be a strong community contributor. And we believe the more that Postgres benefits, the more we benefit. All right. So we introduced a product about 2 years ago called Postgres Plus Cloud Database. It is not a modified version of Postgres or Postgres Plus Advanced Server. It's Postgres, but it's a software system. All right. Postgres Plus Cloud Database is a software system. And it's optimized for cloud environments. Okay, so it's designed to take advantage of and restrict itself to the limitations of infrastructure as a service type environments. So those of you who are familiar with the cloud terminology, infrastructure as a service typically means you can spin up virtual machines running on instances of various sizes very quickly and easily. They can go away quickly and easily. You need to be able to handle that. We're also very interested in the platform as a service, which we see as the next wave of cloud computing. We think the infrastructure as a service has pretty much come down to 3 players. Amazon, obviously, being the biggest. OpenStack, which is a standards effort kind of led by Rackspace, Red Hat, HP, IBM, and others. We think that's going to be a huge player. And the third player is CloudStack, and we view those as the 3 big winners in the infrastructure as a service play, and we run on all of those. We've designed and optimized for all of those particular platforms, or those infrastructure as a service. What we're now seeing, really, we feel, is the platform as a service vendors. People like CloudBees or OpenShift or EngineYard. These are sort of the next wave of computing, and we're trying to pick up on that and plug into those very nicely and be a component that can easily be part of a platform as a service. The infrastructure things that people want to do in the cloud, being able to spin things up quickly and easily, they also want to be able to do in their data center. So we're supporting those scenarios. And private clouds, I mentioned CloudStack and OpenStack. We view that as the up and coming world of the private cloud. All right. But the idea is that when you're dealing with Postgres Plus Cloud Database, you have the same user experience regardless of what cloud platform you're on, either as a platform as a service or an infrastructure as a service. All right, I'm going to give a demo a little bit later, but I just wanted to show you a little bit of what it looks like. This is the interface. This is showing you a master with 2 replicas running on the Amazon cloud. And as I say, I'll give you a full demo a little bit later in the presentation. So here were the goals that we wanted. We wanted to teach people to have very quick experiences, to have a database up and running in 10 seconds that was optimized for the environment you're running on, the hardware you're running on. So if it's a Postgres database, you're spinning it up on a 16 gigabyte instance, you set shared buffers appropriately, you set workmen appropriately, and it just comes up quickly and easily, and 10 seconds later you're pointing your application. Being able to dynamically scale. One of the promises of the cloud is on-demand capacity. If my workload goes up, I add compute resources to handle that. Now, we are not breaking the relational model. We're preserving the relational model. So this presents some challenges in doing this, in the sense that a lot of the NoSQL databases break the relational model so they can do horizontal scaling quickly and easily. So I'll talk about what we can do and we can't do in this area. Typically, but to read it, we do more of the read scaling horizontally very quickly and easily. When the load reaches a certain capacity, we add a read replica just dynamically, and the cluster doesn't need to reconfigure. The application doesn't need to know about it. We also wanted to provide a cost model that was consistent with cloud computing, all right, with the many things. So people, what we're finding is this is kind of taking us into a new business area. We've traditionally dealt with enterprises of, maybe 2 to 10,000 people. As we're dealing with startups who are building their whole new platform in the cloud, they're building their business in the cloud. Really, they're spinning up something like. I don't know, some startup. One of our common startups was a company that was called eGraphs, where you could effectively you would sign up to get an autographed photo of your favorite celebrity. But this was a type of it was a small 10-person company doing things. So they wanted to be able to pay by the hour for their database usage, and this was part of our goal to enable that. Okay, so as I said, we're dealing with a new class of customers. This is sort of how things have worked out for us the first couple of years. We have a new class of customers, lots of startups. As I say, traditionally we're dealing with enterprises who are on Oracle and wanted to migrate off. Now we're dealing with a lot of startups with a whole other set of demands, which has been good. We feel we've been able to make money off the cloud. We'd like to make a lot more, obviously, but it's a very predictable and growing revenue. We just see more and more customers. More and more startups, new businesses they're not buying data centers or investing in it. They're starting on places like Amazon or HP Cloud Services. And we're getting to come up with them and grow with them. And every month we get a little bit more, and it's nice. Amazon gives us, here's what you made, here's what we made every month. We're starting to integrate with the platform as a service vendors, and that's going well. We have a different set of expectations from customers. One thing we found out very quickly is if people point their browser at something you've put up there, they don't want to do any maintenance of it. They expect you to maintain it, all right? They view it as a database as a service. And so we've had to adjust the way we behave and deal with that. All right, and we're finding a lot of interesting ways that we have to optimize for each particular cloud environment. All right, so here's the fundamental architecture of how Postgres Plus. I'm going to give you first the high-level architecture, and I'll do a little more of a deep dive architecture, and then take you through how we handle a couple scenarios. It's a web app. The way you interface with it is a web app. All right, so you point your web browser at it, and you create a cluster. Your cluster consists of a master and one or more replicas. All right. And you can dynamically add and subtract the replicas based on your load. You can also dynamically add and subtract storage. Actually, you can only add storage. We don't let you subtract storage based on your load. Okay. All right. Looking at this a little more detailed, here's how it works. We have we have one single cluster manager. There's one of these in every particular cloud region. So we now support 4 different Amazon regions, and we have one central console that all the users in those regions will use to create clusters. So people will decide if I'm creating an application in US East, they will log into our US East console, and they'll create a cluster. We use something called JClouds, which is an open source project that abstracts the infrastructure as a service piece of a cloud deployment. So we never actually make a call to Amazon, Amazon Web Services, or HP Cloud Services. We make a call to JClouds, and there's a JClouds provider for each particular cloud provider. All right. What we do is, as I mentioned, we create a cluster. We use a cluster management technology called JGroups, which is the same cluster management technology that's in Tomcat, the same cluster management technology that's in Red Hat Cluster Suite. So it's very robust and very proven. Okay? And there's a heartbeat that takes place between the instances in the cluster and the cluster manager. So the cluster manager is constantly managing the instance of the cluster and the overall health of the cluster. And depending on what's happening, we can catch particular events about what's happening in the cluster and take particular actions that the cloud enables us to take that a traditional data center would not. All right, so to give a use case here. Let's say the cluster manager is monitoring one of your servers for how much storage is available. All right, so let's say I set a threshold that when I get to 90% of my storage full, I want to add more storage to the instance. And it just happens. You don't need to interact with it. You don't need to provision. You don't need to call up your storage vendor. You don't need to schedule a maintenance window. The storage just gets added quickly and easily. You don't need to worry about it. And you can come in the next day and say, oh, I crossed the storage threshold, and I'm all set. Okay. Another scenario that we support is effectively your read load is starting to spike. You have, I've said it when I have over 50 connections, I want to add another read replica. When I have over 50 active connections to the database, I'll add a read replica. All right. So the replica gets added, and again, it's as though nothing happened, and it just expands with the load. All right. Any questions so far? Okay. Another use case we support is failover. All right, so again, the cluster manager was continually monitoring the health of the node and the health of the cluster with this JGroups heartbeat. And it'll look at it's looking at the master, and let's say the master fails. Okay, for some reason the master goes away, it dies, the database server dies, somebody accidentally shuts down the Amazon instance, which I'm going to attempt to show you in a live demo later, although I'm a little spooked about it, but we're going to try to do it live. The Amazon instance goes away. There's 2 ways you can fail over in the cloud. Okay, the very obvious way you could do is fail over. The way Postgres does it today is it'll fail over. You set up very nicely with streaming replication to fail over to a replica. All right, so the master goes away. I fail over to the replica. I redirect the load balancer to the replica, and I lose the connection, but my outage time is minimal. That in the cloud can take, we've timed it, it usually takes about 30 seconds, the whole failover process for detection over to, so you have like a 30-second outage, which is nice over the data center. One thing I will say about failover, it's good we have it, because as many of you find, failures are happen a little more easily in the cloud, or seem to happen a little more easily in the cloud. Amazon has gotten significantly more stable over the past 18 months. But in the early days, we would encounter a number of issues where failures would occur. Okay, now that's failing over to a replica. That's something you can do with a little bit of jury rigging in your data center today. But one thing that's very nice about a cloud environment is you can detach things and move them to other devices. So another way you can fail over is when the master goes away is to spin up a new master with the same software on it, and migrate the storage from the old master, the failed master, to the new master. And that's very nice because that's a zero transaction loss failure. It takes a little longer because you have to wait for the instance to spin up. But you don't have the situation where you have an asynchronous streaming replica with a lot of load on it, potentially costing you. Okay, so that's a little bit of. Oh, I'm sorry. Question. Yes. Yeah. So what you do is the cluster manager is monitoring the health of all the nodes in the cluster, and if it detects the master's failed, it initiates the failover process. That's right. And as I said, tuning that appropriately for each cloud environment takes a lot of work, but we do that. We do that for you. Okay, so let me give you a demo of Postgres Plus Cloud Database. Okay, so I'm going to log in to the US East console here. Okay. So this is what you would get when you'd first log in. It tells me how many instances I have running, how many events have occurred. These are things like creating replicas or people connecting or whatever. And it gives me how many snapshots I might have. All right, and I'll talk a bit about that in a second. Okay, right here. All right, what I have here is you'll notice there's various things. I get announcements, anything that's happened. This is again having sort of a database as a service type environment. You can, if there's an Amazon service outage or is there anything we want you to be aware of, we can tell you. What we're always doing here is we're always publishing new how-tos. So when you log into the console, you have things about how to do an Oracle migration, how to use PostGIS. This is a dynamic page that we're always updating our customers with additional information. Okay. So now if I click on the Clusters tab, it's going to tell me which clusters I have available. All right, so I have a production cluster, I have a development cluster, and I have a clone of my production cluster. Okay, when I click on the cluster, it's telling me that I have a master. Okay, there's my load balancer port. There's my master, and here are all my read replicas. All right, so I'll take you through the process of what it takes to how you go about creating a new database cluster. All right, I just specify a cluster name, so we'll call this the PG Open Demo Cluster. In this case, because I'm creating it on Amazon, it will tell me I can specify what type of Amazon machine class I want. So Amazon has predefined configurations with memory and storage. So for this demo, I'll create an M1 large, which is I think about 8 gigabytes of memory. How many nodes I want in the cluster? Okay, a master and how many replicas? So I'll give this 2 replicas. Actually, just in interest of time, let's make it 1 replica. And how much storage I want. All right, so I'll make this with 50 gigabytes of storage. And you create the Postgres user and the Postgres password. All right. So next. Okay. Now the next thing it'll ask me, and then this is another nice optimization of the cloud. It'll ask me how many backups do I want to retain, and when I want my backup window to be. So I'm going to retain 1 backup, and I'm going to do it between 12 a.m. and 2 a.m. in the morning. Okay. So I launch that, and it goes about. It's now creating me a new. It's creating a new cluster for me. Okay, and that'll what it's going to go through this process of creating the network, spinning it up, and doing the various activities that'll happen. Now, while that's going, I'm going to show you some of the other things that are part of Postgres Plus Cloud Database that you'll so it's going to take a few minutes to create that cluster. But before I do that, I created a backup. Backups are done with Amazon Snapshots, and I'll talk about how that's in the case. Again, that's something we do for particular cloud providers. Okay, so I have here. It tells me I'm looking now at my production cluster that I have set up here. It tells me when I created the cluster, how much storage is available, and then which region of Amazon it's in, what version of Postgres it's using. And then I have the configuration. I'll talk about how you set up configurations by default. But we do everything we can to optimize for your particular configuration ahead of time. So it's just setting those critical Postgres parameters, such as shared buffers, wall log segments, etc. All right. Then you have two failover methods. You have two ways you can fail over. All right. One, or we call the the healing mode. One is to replace the master with a replica, which I've set up to do. Replace it with a new master, or I can change it to replace it with a replica. One thing that's very nice, at least in the Amazon world, is the replicas are actually in a different data center. They're still in the U.S. East region, but they're in a different data center. So if a particular Amazon data center goes down, your replica can spin up. Your replica is available in a separate data center. So it's a very nice, it's actually handles geographic failover. It won't, if all of Amazon East goes down, well, then you lose for a period of time. But the good news is you lose with a lot of other people. We had that. We actually had one outage for customers where the West went down, and people were just so relieved that it was okay that they were down because Netflix was also down, which happens to run on Amazon. So sometimes being in good company is all people want. Okay, so I talked about the thresholds. All right, so what this is saying is I'm going to add storage when 65% of the storage, my existing storage, is used. It'll add additional storage. Okay, and then when I have 31 connections, it'll add another replica. So I'm just going to increase that. Okay. Let's see, how am I doing on time here? All right. What you can also do is you can create parameter groups. So these are all the runtime parameters in Postgres that don't require a restart. So I can assign parameter. I can create new parameter groups, and I can change if I wanted to change work mem, for instance. I could set a new value for it. I'll double it. And then I could take this. Then I could have this. I could take this parameter group, and I can assign it to a cluster. All right. So I can create settings that I like for particular database clusters, and then I can just assign them random, and I can have that as something I can assign over and over again. So if I know I want shared buffers to be certain sizes for certain kinds of workloads, I can do that. All right. So okay. So my cluster is created. So we'll go in and do some fun stuff with that. One thing I can go about doing, this actually happens a lot, is somebody calls us up and they say, oh, my load is going through the roof. I really don't want to add another read replica because of the cost, and a lot of my workload is very write intensive. But what can I do? What this allows me to do is is to create a new cluster based on my existing cluster. And I can specify, I can actually change the Amazon instance type. So if I go to an M2 double large, that's a 32 gigabyte machine. And then I can transfer the elastic IP address so that that it's just a transparent scale. So in other words, it takes on the new IP address of the old cluster, and it reattaches the storage to the new machine. And all of a sudden, like that, I've scaled to from an 8 gigabyte machine to a 32 gigabyte machine. I didn't have to call up, order a bunch of memory, schedule a maintenance window. It just happens for me transparently, and I'm up and running, and away I go. All right. Okay. Let's go back to. I can also do it. I can add. I can just go to a particular cluster, and I can do these things manually. If I want to just add some storage, I won't add any replicas here, but I'll add just a little bit of storage to. Let's add 1 gigabyte to the dev clone cluster. Scale it up. And so when that completes, I'll have additional storage. So that's okay. So that's adding my storage to my new cluster. Okay. Another thing that's, again, this is another nice optimization of the cloud. The fact that I can just reattach storage is that I can do minor upgrades very quickly. So I'm currently running Postgres 9.2.4, which is the latest maintenance release for Postgres. There's a new one coming out, I think, next month. But when that comes out, I don't have to log into my server, tell everybody, okay, stop, be careful, I'm going to do a minor upgrade. I come in early in the morning one day, and I just hit this button, and I'm upgraded to the latest, greatest version of Postgres. No, very simple maintenance window. I don't have to concern myself with it. And again, the way it does that is it has a new Amazon virtual machine image that it spins up, and when that new machine image is ready, it just takes the storage from the old machine image and attaches it. All right. And so it's just the time that the Amazon takes to take the storage from the old machine image to the new machine image is your maintenance window. Typically, it takes about 10 seconds. And now I'm up to the latest, greatest security patch of Postgres and all the various maintenance fixes. Okay, I can perform a backup. So I just created. Maybe I make this the. I'll make this the. Actually, let's not back up that one. I'm going to keep that cluster. Okay. So it's So that's creating a backup for me, and it's saving. What it's doing here is it's telling me it's saving the attached volumes. All right, and it'll be available. And if I actually go to my backups, and all the backups I've created, it'll tell me when I created, what sort of notes I added, and I can actually select one of them, and I can restore it. And what it'll do, as opposed to restoring it to an existing cluster, it can restore it to it'll restore it to a new cluster, and I can specify what type of machine I'd like that new cluster to be. This is a very common thing. So I have, if I have a production server that's facing my web app, and I want the developers to start looking at some issue that's related to the production data, I can take a backup. Backups happen very fast, in a matter of under a minute, because all we do is, again, and this is in the case of Amazon, we just take a snapshot of the data directory and the log directory, and we archive that. And so that happens in about 30 seconds. So I can take a snapshot, and then I could clone the backup to a new cluster that my developers could start looking at, or my QA team could start looking at. Right? And I can specify what sort of machine size I'd like it to go. So I'll call this the restore cluster. So I got all sorts of clusters. I'm probably running up quite a bill on this particular talk, but that's okay. Okay. In addition, it also what it's showing here are some monitoring tools we have. We're going to be, as I said, we're a database product company. We'll be, Dave Page and team and Hans Hrasna will be integrating these our full-scale monitoring products together with us. But for right now, we just have something where I haven't done much activity on these particular clusters, but you can see what's happening here. What this is showing me is the data space I've used over a period of time. And it's telling me this is my threshold. When I hit this the percentage here at this red line, it's going to add additional storage. Okay, and this is showing me how many connections I have active. Right now, I have very few, but I could potentially have I potentially could have a load spike, and then I could just actually go back and look and see what's happening. Don't Skype me. All right. The other thing that I can do is, again, this is not a full-scale database as a service. It's meant, at least right at the moment, we're trending towards offering this as a service at some point in the coming year, is that I can actually log into these instances and I can perform, I can actually see what's happening. In order to do that, I would just download I need to download the SSH key for a particular instance, and then I can log in. So once I've downloaded my my .pem key, and you'll notice this is the name right here is the name of the cluster I created. Okay, and then I've logged into it, and I can if I go to we always install Postgres and /opt. Actually, what I should do the polite thing here. This is a management thing here. Logged into a live database cluster as root. And then let me switch to the Postgres user. All right, and then and so anyhow, so I can, if there's various things I want to do on the system, if I want to actually, we've done everything we can so that you don't have to actually physically get on the system and start doing things. But if you need to, you can. It's there. You can do what you need to. You're not locked out. If you wanted to run with some particular operating system patch or extension, you could do it. One other thing you will need to do, if you're using this, you'll notice that I talked about the parameter groups. And the parameter groups are only for parameters that don't require a database server restart. If you did want to change some of the parameter groups, the shared memory settings, etc., that required a database server restart, you would have to do that logged into here. So it's not completely automated, but it's getting as close as we can. Okay, any questions so far? Let's do one thing. Yes, all right. Okay. So we're going to try, for the grand finale here, we're going to try and attempt a failover. I can show you, we show this live, so gentle with me, please. I've never done this in a live demo here, but right as we speak, Dave Page is on Skype with Hans Hrasna. We're going to do this on the development cluster. He's actually going to fail the master. Okay, so this is a master and one replica. We're going to attempt to failover to a replica. All right. So Hans, would you please, Dave, would you please signal Hans to who's lying lie is going to actually kill this replica, and we'll see if we can see this master and see if we can make that happen live. Okay. So I'm not. We're okay. He's on it. Okay. So it'll take a little time for the cluster to notice it. All right. All right. While that's going on, we'll come back, see if all works as we were planned. I want to just talk about some of the features we'll have for this product and things we're looking at, and people can certainly give us feedback in any sense. So one thing that we've discovered is people start using this console. They like the fact that they can dynamically add storage, that they can quickly add replicas, that they quickly can easily provision databases. They don't need to. We're finding a lot of people want to do this in their data center. Yeah, that's great. You can do it out on Amazon. But I'd like to be able to do that in our data center. And we're coming with an architecture based on RPM distribution. And it'll be a Linux-only thing where we can actually push deployments out very quickly and easily and provision them, then add replicas from a list of pre-configured IP addresses. But this will work not only for private clouds, where we're seeing a lot of things like bare metal, things like OpenStack, on OpenStack, but this will happen in any traditional data center. Right. It's currently replacing. Does he tell me should I go back and look? All right, let's go back. Let's go back and have a peek here. Oh, okay. This is it. So the failover is occurring. So it's saving. Yeah, it's saving the attachment. So what's actually happening here is it's actually migrating it's making a snapshot of the volumes, and then it's gonna do the failover. And you could actually see this happening. You could wait. Doug, question? Yeah, the notification right now. So I logged in with an email address. Every time there's some sort of event of any particular occurrence, it will send an email to that the email address I've logged into. We're going to be looking to do SMTP traps initially, but we'll be integrating this with our Postgres Enterprise Manager functionality, which has a very sophisticated and detailed notification mechanism, and so that'll be our long-term strategy. So for the moment, just emails on particular events related to the cloud, mastering and remastering, those sort of events. But in the future, if you want to say you can get a notification that I have 1,000 dead tuples, or that auto vacuum hasn't run in 2 days, and those sort of notifications are part of our future plans. All right, well, we're still failing over. So this is part of what we're thinking. The other aspect of things we're thinking about is in order to do this, we had to develop a lot of failover technology. Spending many hours getting the pulse right. And one thing that's come out of this that we'll also be offering, we hope later this year or early next year, is just the failover technology was a product from it. So what often happens when you enter a new market, in which case we're entering with the cloud, and again, coming up with all these new types of customers and these new types of scenarios, we're actually finding things in our previous market that people are asking for us to backport. So this has been a real interesting adventure. I don't know if those of you who are just at a show of hands, how many of you have some sort of deployment in the cloud? And when I say, let me qualify, either a public cloud, something like Amazon or HP Cloud Services, or have sort of a private cloud infrastructure that you're working. Okay, I have. Well, okay, thanks. I have a thumbs up, so we'll go back and look at the. We'll just quickly show of hands. How many are currently deploying in either a public cloud or a private cloud infrastructure in their enterprise now? 1, 2, 3. Okay. My guess is, based on what we're seeing, a lot more of you will be in the next 10 years. So we're hoping to be there waiting for you. Well, let's see that. Okay, terrific. So it indeed failed over. All right, thank you. All right, so thanks. We're going to conclude with a successful failover of a cluster in the cloud live here on stage at Postgres Open 2013. So are there any other questions for me regarding this product or things we're doing relative to the cloud? Yeah, question? Do you want to take that one, Dave? Or? I think I set it up to fail over to a new. I thought I set it to fail over to a replica. Did I not? Yeah, it failed over to replica. Yeah, so you failed over to the existing replica, and then you created a new replica with the snapshot, so that you everything was hunky dory in terms of. Okay. Any other questions? Okay, thank you very much.